In this video, we'll discuss different methods for selecting a sample from an overall population. By now, we've looked at many ways to analyze data, but we've left out an important part. How do you get that data in the first place? For example, suppose you wanted to find out how common different modes of transportation are among different students at your school. How would you go about finding that out? It's not really practical to ask every single person in the school. So usually what you do is take a sample of some of the students to try to draw conclusions about the larger population. But how do you decide which people to ask? The method you choose can make all the difference. When you're collecting data, it can be really tempting to just sample a group of people that happens to be easy to access. Say, maybe you ask all the people at the nearby parking garage, because that's when you have some free time. That's called convenience sampling. And unfortunately, it's a pretty bad way to do things. Why? Well, when you're sampling, there's usually some group you want to know something about. That's called your population of interest, though it doesn't have to be people. Your population of interest might be all the cars sold in the US, or all the parts produced by a factory. But suppose your sample only selects certain types of individuals of that population. Then you won't find anything out about individuals that don't share those characteristics. In other words, the sampling frame, the set of individuals that your sample is actually drawn from, doesn't match your population of interest. And that means your results don't represent the population as a whole. In the case of our transportation survey, if the only people you ask are coming from the parking garage, then your sample is going to be heavily biased towards students who drive, and you'll miss students who, say, use public transportation. So resist the urge to use convenience sampling as much as possible. Another thing you might think of doing is posting a poll somewhere, say at a bulletin board in the student center or on social media, and then seeing what responses you get. That's called volunteer sampling, and it's also not very good. When you rely on individuals to select themselves, most of the responses you get will be from people who feel strongly about what you're asking and think it's worth their time to respond. That's why I always take customer ratings on websites with a grain of salt. They're biased toward people with strong opinions. That's especially true when it comes to negative ratings. If you've had a bad experience, you let everyone know about it. While if your experience was run-of-the-mill or even good, you're unlikely to give it a second thought. Okay, what if you get a collection of all the students' email addresses and go down the list, sending an email to, say, every fifth address? That's called systematic sampling. It's a bit better than some of the methods we've seen so far, but honestly, it's not great. The main issue with systematic sampling is that it can miss or sometimes even amplify patterns in your data. Say you're taking every 10th item off a conveyor belt to make sure it meets quality standards. What if it just so happens that a machine is malfunctioning so that every 10th item on the line is defective? You'll probably miss them all, but maybe if things work out just right, you'll think every single item is defective. That's the pitfall of systematic sampling. None of these sampling methods have been very good because they're all biased in some way. So what should we do? Well, the key to minimizing bias is to choose your sample randomly. If you sample randomly, then you're making sure that nobody in the population is more likely than anyone else to get selected. So you're much less likely to end up with a biased sample. The simplest way to do this is what's called a simple random sample, or SRS for short. Each possible sample is just as likely as any other sample. So in our transportation example, that might involve once again getting a list of email addresses, but then using a random number generator to select random email addresses to send your survey to. Now, sometimes your population happens to be divided up into groups, and you want to take those groups into account for your data. There are a couple different ways to do this, depending on if the groups are homogeneous or heterogeneous. On one hand, suppose your groups are largely homogeneous. That is, all the people in each group have something important in common. Then you might want to try stratified sampling, where you deliberately sample some people from each group. For example, you might wonder if what year a student is makes a difference for what kind of transportation they most likely use. So you might sort your email list by year and then decide to ask some freshmen, some sophomores, some juniors, and some seniors, all randomly selected within each stratum, of course. On the other hand, if your groups are largely heterogeneous, that is, each group has a variety of individuals, then you might want to try cluster sampling, where you choose a small number of groups and then you collect data from everyone in that group. For the transportation survey, that might mean sorting the email list by major and then picking 3 majors, say business, anthropology, and psychology, once again, hopefully at random. Once you have your clusters, you ask everyone in your cluster to answer your survey. For large populations, though, even the clusters might be too large to collect data from everyone in the cluster. In that case, you might try multi-stage sampling, where you narrow things down step by step. Maybe select random clusters first, and then select randomly within that cluster. And you can take as many steps as you need to narrow things down and make data collection feasible, as long as you do it randomly. Now, on that note, we keep saying to select things randomly, but how do you actually do that? Well, most software used for statistics has built-in ways to simulate randomness. In Excel, for example, you can use the randbetween function to get random numbers in a certain range. You might get duplicates if you use it multiple times, but you can always throw those out and keep going until you're done. Or there's even a website called random.org that has a whole bunch of features for generating random numbers, shuffling a list, and a whole bunch of other useful applications. All of these tools can help you minimize bias in your sample so that you can use your data to make generalizations about the population as a whole.